Hello everyone, this is Kalpana working as an assistant professor in SNS College of Engineering, working in AITS department. Today we are going to discuss about disk scheduling. In before lecture we discussed about first come first serve scheduling algorithm. So we're done with this, and the next we are going to discuss about shortest seek time first algorithm. So this is a shortest seek time first scheduling. So as we see, the first come first serve algorithm, it functions like uh, once if you receive any request, that will be obviously if the disk controller is busy with some other process, we need to store it in a queue, right? So one after another, what we are going to do, we are going to store the request as it comes. Okay, we are going to put the first request in queue in first position, and second in second, third request in third, and so on. So this we follow usually. So that is the first come first serve scheduling. Okay, and here in shortest seek time first scheduling, so we follow a concept like, first see the head position. Okay, so what is our head position? Just see this question. Given a disk with 200 cylinders and a disk queue with request these things for input output to blocks on cylinders, disk head is initially at 53. Okay, disk head is at 53. Okay, so what you are going to do is, initial head position is 53. So since it is what shortest seek time first algorithm, right? So we need to calculate the shortest seek time. Okay, which request has very shortest, we need to check which request is having shortest seek time, that we have to pick and process that request first. We'll see which one is that. 53 is at initial position. So from 53, we need to calculate this queue request is. We have to subtract this 53 from 98, and 53 minus 183, 53 minus 37, 53 minus 122. So like that if you do, so like that you have to do and find which is having the shortest time. So here if you do that, 53 minus 65, if you do 53 minus 65, you will get 12. Okay, for rest of the things like 98 with 183, 37, you will get a bigger number. So 53 minus 65, you are getting only 12. 12 is the seek time. So from 53, after processing, after reaching 53, your head position is 53. So from 53, it is easy to switch from 53 to 65. That is the meaning. The seek time is only 12 seconds. So that what we are doing, from 53 to 65 we are moving. Okay. So from 65, uh, and again what you have to, now the head position is at 65. Okay, so you have to subtract this 65 with 98, 183, 37, 122, 14, 124, like that. If you do, what happened? So 65, so you have to subtract the 65 with all these numbers, 65 minus 98, 65 minus 183, like that. If you do, what happens? 65 minus 67, you get 2. So 65, from 65 it is easy to reach 67. So next is 67. So from 67, likewise we have to subtract with 98, 183, 37, 122, not 37, 37, 122, and so on. If you do after 67, it is easy to reach 37, okay, because the difference is less. So once you reach 37, from 37 to 14, you get a very less seek time. So likewise, we need to process this. And then once if you reach 14, we can reach 98 and then 124, 122, 124 and then 183, so on. So this is how it functions. So what you have to do, you have to start with the head position 53. So from 53, first you have to subtract with all the request queue, all the requests, disk request. So which one you have to see which request is taking very less seek time. Okay, shortest seek time. So that you have to pick and process the request secondly. And then when you reach the second one 65, then what you have to do is with this 65 you have to subtract 98 and then 65 minus 183, 65 minus 37, like that you have to do it. Okay, so always processing a request, we need to check the before processing a request, we need to subtract that with the, we have to check for the shortest time, shortest seek time. So we have to pick that and process it. So this is how it happens.